and if our scale is less than 1 or greater than 1, and how we would apply that to a figure. Today we're going to scale factor. We're going to look at some of the questions that you had on your assignment yesterday, and then we're going to talk about how scale factor, good morning Samuel, affects perimeter and area of an object. So let me go ahead and let me grab the link here that I want you to have. So there's the link to the Jamboard I want you to go to. I can see Monica's in here, Nathan's in here. There's Yariel. All right. Oh, don't do anything yet. All right, so yesterday we talked about when we scale up or scale down, and we talked about using the ratio of corresponding side lengths to figure out the scale factor. So what is the ratio from B to A? The ratio of B to A is what? Who remembers from yesterday? Okay, so Yariel says in the chat, we said it was 2/4, okay, which is also the same as 1/2, as we know. So what about, how would scale factor affect the perimeter? That's what we're going to look at. So how would I find the perimeter of triangle A? What would the perimeter be? You can write your answer here. You can put it in the chat. What would the perimeter of triangle A be? All right, Yariel and Nathan both say 12. Monica said in the chat 12. So it looks like we're all in agreement that it would be 12 units, because if we add 4 plus 4 plus 4, that would give us 12. All right, what about triangle B? What would the perimeter of triangle B be? Monica says 6, Nathan says 6, Yariel says 6, because 2 plus 2 plus 2 equals 6. Oh, good morning, Jada. All right. What if I wanted you to find the ratio of the perimeter? So the perimeter of B and the perimeter of A. So the perimeter of B to the perimeter of A, what would our ratio be? Okay, remember we're doing B to A, Yariel, not A to B. All right, so I see Nathan says 6 to 12. Yariel, you have A to B instead of B to A. Okay. And if I wrote that as a fraction, I would have 6 over 12. Can I simplify 6/12? Yariel says yes. And if I simplify 6/12, what fraction do I get? 1/2. Or 2/4, we can reduce it down even further to 1/2. So the scale factor for my perimeter is 1/2. And the scale factor for my corresponding sides of my triangle is 1/2. So what do you notice about the relationship between the scale factor of the sides and the scale factor of the perimeter? They are what? What do you notice about the relationship? They are the right. I see Nathan wrote it over there. They are exactly the same. So whenever we are doing scale factor of a figure, if you have a question about the scale factor of the perimeter, your answer should be the same as the scale factor, okay? So scale factor has no, or perimeter, reverse my train of thought there. Scale factor has no effect on the perimeter, okay? It's going to be the same scale factor no matter what. Okay. Questions about scale factor in perimeter? All right, now that we've looked at this one, let's go to slide 2 here. So everybody should be on slide 2. And this should look familiar. It's a problem that you had on yesterday's assignment. And this one deals with area. So a builder made a scale rectangular room. The drawing has a length of 6 inches and a width of 4.5 inches. The actual room will have a length of 18 feet. What is the area of the actual room? So we had to figure out first what our scale factor is. So 1 inch in this scale, or in this model, is equal to how many feet? So every inch is how many in the model? That is this number right here. Okay, I see an answer of 3. And we found that because we know that we have to divide by 6 here, which means we have to divide by 6 here. And 18 divided by 6 is 3. So now how would I figure out how many feet 4.5 inches is? Show me what that would look like. How would I figure out how many feet 4.5 inches is equal to? All right, so we're going to do times 3. And if I take 4.5 times 3, what answer do I get? 4.5 times 3 is... I see Nathan's answer over there, 13.5. So the dimensions of our actual room are 18 by 13.5 feet. So those are our dimensions of the room. Up here it tells me to find the area. We're going to do base times height. So 18 times 13.5 will give me this answer right here. And whenever I do that operation, 18 times 13.5, what do I get? All right, so the area of the room is 243 feet. And anytime we're talking about area, it's always going to be our units squared, okay? So we're always going to square our units. All right, so this represents the actual, okay? What would the area of our drawing be? You mean to find the 243 feet? So Yariel, we took this right here, so the length of the room, times the height of the, or the width of the room, so 13.5, and we found what the area would be. So 18 times 13.5 gives me 243 feet, okay? So now what we're gonna do is compare that to the area of the drawing. So we would take 6, which is our length, times 4.5, which is our width, and that's going to give us the area of the drawing. So what is 6 times 4.5? I see Nathan's already got it written down. So Nathan tells us that when we do 6 times 4.5, we get 27. Jada gave me the same answer in the chat. All right. So I'm going to type real quick. Our scale factor for the actual room is 3. Okay, our scale factor from the drawing to the actual room, we multiplied all the values by 3. What is our scale factor for the areas? Okay, so what is scale factor for the areas? So we're going to look at what is our actual divided by our drawing. So what is the ratio of the actual size to the drawing? So looking at the areas, 243 to 27. What scale factor would you get? All right, Nathan, when you simplify 243 over 27, what number do you get? You get 9 because 243 divided by 27 is 9. What do you notice about these two scale factors? Are they the same? Okay, no, they're not. So when we're talking about scale factor with area, your scale factor for your area is going to increase by whatever this number is squared, because 3 squared means 3 times 3, which is equal to 9, okay? So with area, whenever you find a scale factor for your measurements, if you square that, that is the scale factor for your area. All right. Any questions about that? Yariel, what's your question? All right, if you want to stay on after we're done, whenever it's independent work time, we can go over your questions then. Does that work? Okay. All right, so let me go into this right here. All right, just to review a couple things, and we kind of touched on this already. Whenever we're doing scale factor, remember back to when we did unit rates and we filled in our ratio tables, you're going to work through some of these the exact same way you can build a table. So if I look at this, every 5 feet on the actual building is 2 centimeters on the scale. And if we want to know how many centimeters are on the scale to the actual building, you need to figure out from 5 to 40, what operation, multiplication or division am I doing, and by what value? So 5 times what is going to give me 40, and we know that's 8. And if I do it to one side of the table, I have to do it to the other side. And we would take 2 times 8 to find this value right here. So you should have 16 on this one, okay? So if you get stuck on these, just remember back to when we did ratio tables. And if you want to go back and redo this assignment from yesterday, I'm perfectly fine with that too. We already went over that one. We already went over perimeter. All right. This is what I want to look at right now, because your assignment today is going to be all about scale factor in maps. So if you ever looked at a map, obviously the map is not the actual distance from one point to another. It is all based on a scale. And usually at the bottom of the map somewhere or in a corner, it'll tell you what the scale is. So this many feet or miles equals this many inches on the map. So your assignment today is going to be about using a map scale to figure out the actual distance between points. So let's look at an example. You look at a map of a department store to see how far the following 3 departments are from one another: accessories, shoes, and clothing. The distance between accessories and shoes is a 1/2 inch. So from here to here on the map is a 1/2 an inch. From shoes to clothing is 1.2 inches. And on the map scale, 1 inch equals 50 feet. And they want to know the actual distance between the shoes and clothing departments. So we're looking at the distance here. Okay. So if 50 feet is equal to 1 inch, how many inches or how many feet is a 1/2 inch going to be? What's this number going to be right here? If 1 inch is 50 feet, how many feet is a 1/2 inch? Nathan, how did you get 25? Okay. So 0.5 is 1/2 of 1. So we have to divide by 2 to go from here to here, which means we divide by 2 on this side. And 20 or 50 divided by 2 is 25. All right. How many feet would 1.2 inches be then? Okay, Nathan says 60. How did you get that answer, Nathan? Okay, so we have to multiply by 1.2 to go from 1 to 1.2. So we do that on this side. And 1.2 times 50 gives me 60. So what is the actual distance between the shoe and clothing departments in the store? How many feet? Right. What if the question asked, how far did you walk? Sorry, I was making sure there was no name. How far did you walk in the store if you went from accessories to shoes and then shoes to clothing? How far did you walk? How would you figure that out? $25 plus 60. Well, we're not going to subtract, Monica, because we went from here to here and then here to here. So we're going to add those distances together, okay? And you should get 85 feet because you're going to have a couple problems today that are going to have you add the distances. So just pay attention to what the question is really asking you. Any questions about how we got 60 feet? All right. Yariel will go over it here in a minute, okay? All right. So your assignment today, you do have there are only 3 problems that you're going to do. They're all maps today. Again, pay attention to what the question is really asking. Like slide 2 says, what is the length of the actual race? It's not from one point to another. It wants to know in total, how far did you go? So that's one of those problems you're going to add on. And then when you're finished with that, you do have an IXL that you're going to complete, just one today. Any questions about your assignment for today? All right. If you have no questions, you feel pretty good about this, you are free to go ahead and get to work. I will be here until 10:15. And if you have questions later, I will be here during Red Hawk time. Have a great day. Have a good day, Monica.